In Python, the function is a powerful tool for selectively extracting elements from an iterable, like a list or tuple, based on a given condition. It's a fundamental functional programming concept that can make your code more concise and efficient. The function takes two main arguments, a function and an iterable. The function, often referred to as the predicate, defines the filtering logic. It takes an element from the iterable as input and returns if the element should be included in the output or otherwise. The iterable argument represents the sequence of elements you want to filter. This could be a list, tuple, string, or any other object that supports iteration. The function returns an iterator, not a list. This iterator yields the elements from the input iterable that satisfy the predicate function's condition. To obtain a list of filtered elements, you can convert the iterator using the constructor. Let's move on to some practical examples to see how this works in action. Imagine you have a list of numbers and you want to extract only the even numbers. Using a loop, you'd have to iterate through each element, check for evenness using the modulo operator, and append it to a new list. This task becomes remarkably straightforward. Python numbers =, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, def is even number, even underscore numbers equals sign list, filter is even numbers, print, even numbers, hash output, 2, 4, 6, 8, 10. In this example is our predicate function. It checks if a number is divisible by 2 without a remainder. The function applies this function to each element in the list. For simpler conditions, lambda expressions offer a more compact alternative to defining separate functions. Let's rewrite the previous example using a lambda Python numbers =, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Even underscore numbers equals sign list, filter, lambda x%2 =, 0 numbers. Print even numbers, hash output, 2, 4, 6, 8, 10. As you can see, lambda expressions allow us to define the filtering logic inline, making the code even more concise. Beyond simple numerical checks can handle more complex filtering scenarios. You can use it to filter falsy values from a list, keeping only the elements that evaluate 2 in a Boolean context. Python values =, 0, none, hello, world, false, 10. Truthy underscore values equals sign list, filter, none values, print truthy values, hash output, hello world 10. In this case we pass as the first argument 2. This special behavior tells to use Python's truthiness rules for filtering. Moreover, works seamlessly with dictionaries. You can filter dictionary items based on their keys or values. Python data =, name, Alice, age, 30, city, New York, filtered underscore data =, dict filter, lambda item len item 0, 3, data.items, print, filtered data, hash output, name, Alice, city, New York. Here we iterate over the key value pairs using and filter based on the length of the keys. Section 4, versus list comprehensions. List comprehensions provide a more Pythonic way to achieve filtering, often resulting in more readable code. For example, consider this snippet Python numbers =, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, even underscore numbers =, x for x in numbers if x%2 =, 0, print even numbers, hash output, 2, 4, 6, 8, 10. While list comprehensions are generally favored for their conciseness, remains valuable when working with complex filtering conditions, or when you need to separate the filtering logic from the iteration process. Section 5, Conclusion. Embrace the power of. The function is a versatile tool in a Python programmer's arsenal. Its ability to selectively extract elements from iterables based on user-defined conditions makes it invaluable for data manipulation and processing tasks. By mastering along with other functional programming concepts, you can write more expressive, concise, and efficient Python code. Remember to practice using in various scenarios. Experiment with different predicate functions, explore its use with various data structures, and compare it with list comprehensions to solidify your understanding.